So now that we've had a look at chi-squared hypothesis testing when we have frequencies, we're going to have a look at what we have to do if we don't start off with a contingency table with frequencies. So we're looking at contingency tables with proportions. So if the contingency table contains percentages, we must first change them into the actual frequencies before we can perform the chi-squared test. So here we have an example. In 1996, Ardwick School entered 130 candidates for GCSEs, Bramhall School entered 145 candidates, and Charlton School entered 120 candidates. The percentages of candidates at each school that gained 5 or more C's at GCSE is given in the table below. And then we're asked to test at a 5% significance level whether or not the number of students passing 5 or more GCSEs is independent of the school. So we know that we're going to have to do the chi-squared test because it mentions independent. We're not looking for a correlation or anything like that. It just says independent, so that means that we're going to have to do the chi-squared test. So remember that our H0 is going to be there exists no association between attaining 5 or more grade C's and school, or saying that they are independent. And our H1 is going to be that there exists an association between attaining 5 or more grade C's and school, or saying that they are dependent. So then we need to go into our graphical calculator. Remember that we go to test chi and we're putting it in the two-way table. Then we go to the arrow mat. This is a 2 by 3 because we've got 2 rows and 3 columns. Remember, if you put them in the wrong way around, this table won't look correct. But we can't put in these values here because these are percentages. So that's as far as we can get with that bit. So what we have to do instead is we need to change these to frequencies, and we need to use the information that was given to us in the question. So we were told that Ardwick School entered 130 candidates. We know that 70% of them got 5 or more GCSEs at a grade C. So I'm going to draw another observation table of observed values. So remember that these are still observed values. Just put in the letters of the school at the top. 5 or more, less than 5. Oops. Sorry about that. So then we need to find 70% of 130. So if we're going to the normal calculator part, we can do 130 times 0.7, and that gives us 91. So that means that there were 91 pupils who got 5 or more. and then 30%, so 130 times 0.3, which gives us 39 that got less than 5. So then we're going to have a look at the next school. So the next school was Bramhall. Bramhall entered 145 candidates, and 60% of those got 5 or more. So again, 145 this time, times 0.6 for our 60%, which gives us 87. And then 145 times 0.4 for the less than 5, which gives us 58. Lastly, we have Charlton School, who entered 120 candidates, so Charlton, and then we have 65% of those getting 5 or more, so 120 times 0.65 this time, which gives us 78. And then 120 times 0.35, which gives us 42. And because these are the actual frequencies, these are the values that we're going to type into our calculator. So if I go back into my stat function, remember it's test, chi, two-way. Arrow mat, I've already changed that so it's the right dimensions, and it's these values here that I'm going to put in, and remember it goes across when you enter them, so 91, 87, 78, 39, 58 and 42. Then we need to go back, so we need to click exit, exit, then we need to click exit so the calculator will actually perform the test for us. Remember, don't write these values down straight away. We are going to come back to this as to why we don't write them down straight away. Instead, we need to click on the arrow mat again, go down to matrix B, and remember that these are our expected values. So in a separate table, we're going to have expected values. And then we just need to copy these values at least to 3 significant figures. So then we can come back out of there and we need to write this information down. So the chi-squared value is 3.01 to 3 significant figures. Remember that that's our test statistic. We also need to write down the degrees of freedom, the DF, which is 2. And then remember to use your formula booklet to look up the critical value on page 20. Remember that we're going to use the right hand side to do this, and because it's a 5% significance level, we're going to look down from 0.95. Remember that the little V in the formula booklet is the symbol for the degrees of freedom, so we're looking across from 2, and that gives us 5.991 as our critical value. So that means that this time we are actually going to be accepting H0 because our data is closer, our observed values are closer to our expected values than we need them to be for the critical value. So that means that there probably isn't an association between them. And if we have a look at the values that we have, we can see that although they're not perfect, C is very close. If we were to round them to 2 significant figures instead of 3 significant figures, C would be dead on. B, not a million miles away, 7 out on those 2, and A, again, another about 7 out on those as well. So as the test statistic is smaller than the critical value, we're going to accept H0 at a 5% significance level. There is, remember that we always write about H1, so we say that there's insufficient evidence to suggest an association between attaining 5 or more C grades and school. So I'd now like you to pause the video and give the Now You try a go, remembering to pick the important bits of information out from the question. So hopefully you've paused the video and given the Now You try a go. So again, our H0 is that there exists no association between colour preference and personality, or that they are independent. And then we have that our H1 is that there exists an association between colour preference and personality, or that they are dependent. And again, we have to make our observed values table, so we can see from the information at the top that we had 200 students who preferred red, so that means that these values here add up to 200, so 0.1 times 200 gives us 20, 0.9 times 200 gives us 180. Then we have yellow is 40 people, so we have 0.15 times 40, which gives us 6, and then 0.85 times 40, which gives us 34. Then we have 80 prefer green, so we have 0.375 times 80, which gives us 30, and 0.625 times 80, which gives us 50. And then finally, 80 prefer blue, so we have 0.55 times 80, which gives us 44, 0.45 times 80, which gives us 36. Then when we put that into our calculator, we get our expected values table. Remember, don't write this down straight away. First of all, go to arrow mat, down to mat B, and that's our expected values table. Then we write down our chi-squared value, our test statistic, and our degrees of freedom. We use those to look up our critical value, which in this case ends up being 7.815 at a 5% significance level. So that means that as our test statistic is bigger than the critical value, we reject H0 at a 5% significance level. There is sufficient evidence to suggest an association between colour preference and personality. And we can see here that these values are a lot different to these values. We've got 20 and 50, 180 to 150. We've got 44 to 20 and 36 to 60. So there's quite a bit of difference between these values this time. Please notice how I label everything very clearly, okay? Because you're going to end up having to write 2 tables down for this. And this isn't the only instance where you end up writing more than 1 table. So you need to make it clear what's going on in each table. So this table here, the blue one, is the observed values, and then the purple one is the expected values. And it's very important that you label them up clearly, not only just for marking, but also for your own working later on, so you know what you're talking about when you refer back to the tables. So next we're going to have a look at why we have to write the expected values table down before we write down the chi-squared value in our pooling video. Thank you very much for listening.